Hey guys, this is Carrie, and this is the answer key video for homework number 9. So the population of dolphins in a small bay numbers 45 and grows at a rate of 7% each year. Write the discrete and continuous equations for the population of dolphins, P of t, in the small bay as a function of time t. So the discrete formula is the one where we imagine that this whole 7%, we're getting that once per year. So we get that whole change all at once. So in year 0 years have passed, we get 45 dolphins. And then at the end of that year, we get all 7% all at once. So we have 100% of the dolphins we had before, plus an extra 7%. So the way that formula will look, if we write it mathematically, is P of t is equal to 45 dolphins times 1 from the 100 plus 0.07 from the 7%, doing a 7% divided by 100 to the t power. And the reason why it looks like this is we're multiplying by this once per year. So every year that goes by, we multiply by this. Now, continuous exponential growth works a little differently. We're getting 7% population growth per year, but instead of happening once per year like this, continuous exponential growth is always happening. So we get a little bit of that 7% each step along the way. And the steps are really small because it's continuously changing. It's changing over time in a continuous way. So we get a little piece of that 7% each step. And what ends up happening when we did the math behind this is our formula transitioned from something that looked like this to a brand new looking formula, P e to the RT. So we don't have to understand how that transition worked to apply it. What we do need to understand is P of t is equal to 45 dolphins to start times e to the r, and r in this case just comes from the 0.07. We don't include the 1 like we did last time, times t. A dosage of Tylenol is 150 milligrams. The body processes Tylenol at an hourly rate of 34% every hour, meaning that the amount of the drug increases by decreases, wow, keyword, by 34%. Write the discrete and continuous equations for the amount of Tylenol in the body, A of t, as a function of the time t. So here, because it's decreasing by 34%, we would say the amount of Tylenol for the discrete case starts off at 150, and each hour we keep 100% what we had before, but then we lose 0.34 or 34% every hour. So each hour that goes by, the multiplier is going to be the result of this. Now, oftentimes we do that calculation all at once. This comes from the 100% minus the 34% that we're losing, which would mean that we have 150 times 0.66 to the t power. Because when you subtract these, you get 66%. So either one of these answers could be correct. Sometimes it's useful to see the r separate. Sometimes it's useful to see everything together. If you do the subtraction, you get the same result. The continuous formula, though, is always going to be written in the form A equals P e to the RT. So we have A of t is equal to P, 150, times e to the 0.34t. Now, hopefully you notice there's a mistake here. Because it's decreasing by 34%, it's to the negative 0.34t, and that's important to keep in mind. Otherwise, we'd say the amount of Tylenol would be increasing. The formula for continuously compounded interest is A equals P e to the RT, where A is the amount of money in the account, P is the initial investment, R is the interest rate, and T is the time in years. Using the formula, determine to the nearest dollar the amount of money in the account after 8 years if $1,000 is invested at an annual rate of 6%. Because this one uses the phrase continuously, we know we're using A equals P e to the RT as our formula. So A of t is equal to P, $1,000 is invested, times E, because E is always the number E, R is 0.06, because we want to write that as a decimal, and then t. In particular, we want to know the amount after 8 years, so we just need to plug in 8. So we get 1,000 times e to the 0.06 times 8. So going into Desmos, we do 1,000. I think it was 1,000. Let me just check. It's hard to remember. 1,000 times e to the 0.06 times, So you notice that the times came out of the parentheses, or out of the exponent there. So what we need to remember to do on a lot of the calculators is use parentheses. So 0.06 times 8. Cool. Oh, wow. Cool. All right, so that's $1,616. Which may not sound like a ton of money in comparison to $1,000, but to get a free $616 after 8 years is really nice because of the compound interest. It does say to the nearest dollar, so let's make sure we rounded that correctly. Okay, it's 0.0, so because of the 0 there, we'd round it to 1616, which is exactly what we got. For the next problems, solve each of the following equations for the given variable. So here, to isolate x, the opposite of logs are bases. So we use a base of 3 raised to each side. Bases and logs cancel out, giving us x equals base 3 to the 5th. Remember, this is the base, so this means that this is the exponent. And now when we do 3 to the 5th, we get 243. For this one, to get x by itself, we need to get rid of the base. So because bases and logs are opposites, we use log base 4 on both sides. Logs and bases cancel out, giving us x is equal to log base 4 of 640. And to put that in your calculator, you do log 640 divided by log of 4. If you don't have a calculator at home, you can use Desmos to do all of these calculations. So you would go to desmos.com, and your calculations should look exactly like this. Functions miscellaneous log 640 divided by functions log 4. So 4.66. All right, now today we learned really important. E is a special base. And you could do log base E to cancel out a base of E. But because log base E comes up so frequently in all of these exponential growth problems, you have a base of E. Because it comes up so frequently, we give log base E a special name. It's the same thing as ln. So we do ln, the natural log on both sides, ln, the natural log on both sides. Ln and E and base E cancel out, giving us x is equal to ln of 777. And you'll notice that this is much easier to type in on your calculator. For ln of 777, you can just type in functions miscellaneous ln 777. Cool, so 6.66. All right, so you guys can do D, because it's very similar to what we saw before, and you guys can do F, but we're going to do E together. So to get rid of the ln here, so x is by itself, because E as a base and ln are opposites, we do base E to both sides. Base E and ln cancel out, giving us x equals E to the 3rd. So we get x is equal to E to the 3rd. So 20.09. All right, I hope you guys found this video helpful. We're going to be reviewing for our test next class. So if you have any questions, please write them down so you can make a point to ask them, and we can go over them. Bye, guys. See you next period.